Hello children, today we will talk about logarithms. Before the calculators and computers came into picture, people used to do multiplication and division of large numbers using logarithms. It was possible to compute such kind of expressions in a matter of few steps using log tables. Today with mobile in hand, using log tables is kind of obsolete. Let us see the definition of logarithm. Logarithm is defined as the exponent or power to which a base must be raised to yield a given number. For example, we know that 3 to power 4 is equal to 81. So we say that 4 is the logarithm of 81 to the base 3. We write it as 4 is equal to log 81 to the base 3. In exponent form, we write it as 3 to power 4 is equal to 81 or base to power logarithm is equal to number. In general, a to power x is equal to n means x is equal to log n to the base a. Condition on n and a should be n should be greater than 0, a should be greater than 0, but a should not be equal to 1. There are three limitations of logarithms. First one we have seen here. X is equal to log n base a means n should be greater than 0, a should be greater than 0 and a should not be equal to 1. Second condition, logarithm of 0 does not exist means n should not be equal to 0. Third condition, logarithm of negative real numbers is not defined means n cannot be less than 0. Now let us see three important results. First one, log 1 to any base is equal to 0. Second one, log of a number to the same base is equal to 1. That means log a to the base a is equal to 1. Third one, log of a number to its reciprocal base is equal to minus 1. That means log of a to the base 1 by a or log of 1 by a to the base a is equal to minus 1. Now let us see the properties of logarithms. There are 8 properties we will see one by one. First one, product law. Log of mn to the base a is equal to log m to the base a plus log n to the base a. Second one, ratios law. Log of m by n to the base a is equal to log m to the base a minus log n to the base a. Third one, powers law. Log of n to power p to the base a is equal to p times log n to the base a. So this power can be shifted here. Fourth one, roots law. Log of qth root of n to the base a is equal to 1 by q log n to the base a. Alternatively, this can be written as this. Log n to power 1 by q to the base a is equal to, now using powers law, 1 by q can be shifted here. So it will be equal to 1 by q times log n to the base a. Fifth one, change of base law. Log a to the base b is equal to log a to the base m upon log b to the base m. Sixth one, log a to the base b into log b to the base a is equal to 1 or log a to the base b is equal to 1 upon log b to the base a. Seventh one, a to power log c to the base b is equal to c to power log a base b. A and c can be swapped. Eighth one, log m to the base a to power k is equal to 1 by k log m to the base a. So this power can be shifted here as reciprocal of the power. There are two types of logarithms. One is natural logarithm and the other is common logarithm. Natural logarithm is taken on base e. For example, log 2 base e. It is written as ln2. Common logarithm is taken on base 10. For example, log 2 base 10. Value of e is approximately 2.718. Let us see how to interchange these two logarithms. As per base changing rule, we can write log a base e is equal to log a base 10 upon log e base 10. Value of e is 2.718. So from log table, we can calculate 1 upon log 2.718 to the base 10. Comes out to be 2.303. So log a base e is equal to 2.303 log a base 10. One log can be calculated knowing the other. Now let us see a couple of questions based on logarithmic properties. First question, log x to the base a is equal to m and log x square to the base b is equal to n. Then log root ab to the base x is equal to. It is given that log x to the base a is equal to m and log x square to the base b is equal to n. This power can be shifted here. So 2 log x to the base b is equal to n. Take 2 to the other side. So log x to the base b is equal to n by 2. We have to calculate the value of log root ab to the base x. Root ab can be written as ab to power 1 by 2. This power can be taken here. So 1 by 2 log ab to the base x. This can be simplified as log a to the base x plus log b to the base x. And log a to the base x can be written as 1 upon log x to the base a. And log b to the base x can be written as 1 upon log x to the base b. We can substitute the values of log x to the base a and log x to the base b from here and here. So it will be 1 by 2, 1 upon m plus 1 upon n by 2. Now 2 will go to the numerator. So it will be 1 by 2, 1 by m plus 2 by n. After removing the bracket, it will be 1 by 2m plus 1 by n. Second question, log 9 to the base 8 into log 8 to the base 7 into log 7 to the base 6 into log 6 to the base 5 into log 5 to the base 4 into log 4 to the base 3 is equal to what? Notice here that one's base is other's number. So we can apply base changing theorem here. Log 8 to the base 7 can be written as 1 upon log 7 to the base 8. Log 6 to the base 5 can be written as 1 upon log 5 to the base 6. And log 4 to the base 3 can be written as 1 upon log 3 to the base 4. Now combine two numbers. So it will be log 9 to the base 8 upon log 7 to the base 8 into log 7 to the base 6 upon log 5 to the base 6 into log 5 to the base 4 upon log 3 to the base 4. This will be equal to log 9 base 7. This will be equal to log 7 to the base 5 and this will be equal to log 5 to the base 3. Log 7 to the base 5 can be written as 1 upon log 5 to the base 7. Now combining these two, it will be log 9 to the base 7 upon log 5 to the base 7 into log 5 to the base 3. Now this will be equal to log 9 to the base 5 into log 5 to the base 3. Log 5 to the base 3 can be written as 1 upon log 3 to the base 5. So this will be equal to log 9 to the base 5 upon log 3 to the base 5. And this will be equal to log 9 to the base 3. 9 can be written as 3 to power 2 and this power can be shifted here. So it will be 2 log 3 to the base 3 and we know that log a to the base a is equal to 1. So this will be 2 into 1, that is 2. Now let us see a couple of important observations. Point number 1, if base of logarithm is greater than 1, then logarithm of greater number is greater. For example, log 3 base 10 is greater than log 2 base 10. If base of logarithm is greater than 1, then logarithm of greater number is greater. Second point, if base of logarithm lies between 0 to 1, then logarithm of greater number is smaller. For example, log 27 to the base 1 by 3 is less than log 9 to the base 1 by 3. It can be simplified as log 3 to power 3 to the base 1 by 3 and this power can be shifted here. So it will be 3 log 3 to the base 1 by 3. And we have read that log a to the base 1 by a is equal to minus 1. So it will be minus 3. And this can be simplified as log 3 to power 2 to the base 1 by 3. This power can be shifted here. So it will be 2 log 3 to the base 1 by 3. And we have read that log a to the base 1 by a is equal to minus 1. So it will be minus 2. Clearly, minus 3 is less than minus 2. Point number 2. When the number and the base are on the same side of unity, logarithm is positive. For example, if number and base both are greater than 1 or number and base both lie between 0 to 1, so logarithm will be positive. Second point, when the number and base are on opposite side of unity, logarithm is negative. For example, if number and base, number is greater than 1, base lies between 0 to 1 or the opposite. If number lies between 0 to 1 and base is greater than 1, so logarithm will be negative. Now let us talk about characteristic and mantissa. Logarithm of a number can be divided into two parts. One is integer, another is fraction. Integer part is known as characteristic and fraction part is known as mantissa. Point number 1. Mantissa is always positive. If the logarithm of a number is 2.34, so it can be written as 2 plus 0.34. This is integer, this is fraction part. So characteristic is 2 and mantissa is 0.34. If the logarithm of a number is negative, for example, minus 3.52, so it can be written as minus 4 plus 0.48. So characteristic is minus 4 and mantissa is 0.48. You may notice here that mantissa is always positive. Second point, if the characteristic of log x to the base a be n, then the number of digits in x is n plus 1. We will see one question based on this point. Third point, if the characteristic of log x to the base a be minus n, then there will be n minus 1 zeros between decimal and first significant digit after decimal. We will see this question based on this point. First question, find the number of digits in 36 to power 15. We will take the log of 36 to power 15 to the base 10 to figure out characteristic and mantissa. Log 36 to power 15 to the base 10, 15 can be shifted here. So it will be 15 log. 36 can be written as 2 to power 2 into 3 to power 2. Now this part can be expanded as log m to the base 10 plus log n to the base 10. M is 2 to power 2 and n is 3 to power 2. So it will be 15 log 2 to power 2 base 10 plus log 3 to power 2 base 10. Now this power can be shifted here and this power can be shifted here. So it will be 15 2 log 2 base 10 plus 2 log 3 base 10. 2 is common, can be taken out. So it is 15 into 2 log 2 base 10 plus log 3 base 10. Value of log 2 base 10 is 0.3010 and value of log 3 base 10 is 0.4771. So it comes out to be 23.343. Characteristic is 23 and mantissa is 0.343. So we have figured out n is 23. This n is 23. So number of digits in this number will be n plus 1. That is 23 plus 1, 24. Second question, find the number of zeros between decimal and first significant digit in 1 by 12 to power 100. We will take the log of 1 by 12 to power 100 to the base 10. 100 can be shifted here. So it will be 100 log 1 by 12 to the base 10. This can be expanded as log 1 base 10 minus log 12 base 10. Log 1 on any base is equal to 0. 12 can be written as 2 to power 2 into 3. So this can be expanded as log 2 to power 2 base 10 plus log 3 base 10. Now power 2 can be shifted here. So it will be 2 log 2 base 10 plus log 3 base 10. Value of log 2 base 10 is 0.3010 and value of log 3 base 10 is 0.4771. So this comes out to be minus 107.91, which can be written as minus 108 plus 0.09. So the characteristic is minus 108 and mantissa is 0.09. So we have figured out n. So n is 108. So number of zeros between decimal and first significant digit after decimal is n minus 1, means 108 minus 1, that is 107. Now let us see a couple of questions based on logarithmic equations. First question, solve for x. Log x to the base 2 plus log x to the base 4 plus log x to the base 8 is equal to 11. First step is to make the bases same. 4 can be written as 2 to power 2, 8 can be written as 2 to power 3. So we can shift this power here as reciprocal of power. So it will be log x to the base 2 plus 1 by 2 log x to the base 2 plus 1 by 3 log x to the base 3 is equal to 11. Take log x to the base 2 common in all three. So it will be log x to the base 2, 1 plus 1 by 2 plus 1 by 3 is equal to 11. So it comes out to be log x to the base 2 is equal to 6. Now we can write it in exponent form as x equal to 2 to power 6 or x equal to 64. Second question, solve for x. Log x to the base 2 minus 3 log x to the base 1 by 2 is equal to 6. 1 by 2 can be written as 2 to power minus 1 And now this power can be shifted here as reciprocal of power. So it will be log x base 2 minus 3 into minus 1 log x to the base 2 is equal to 6, or log x to the base 2 plus 3 log x to the base 2 is equal to 6, and that is equal to 4 log x base 2 is equal to 6. Take 4 to the other side. So log x base 2 is equal to 6 by 4, or x equal to 2 to power 3 by 2. And 3 by 2 can be split as 1 plus 1 by 2. And this can be split as 2 into 2 to power 1 by 2. That is 2 root 2. Now let us see logarithmic inequalities. There are 4 formulas related to logarithmic inequalities. However, we can solve questions related to logarithmic inequalities by our usual analytical approach. Let us see how to do that. First question, solve for x. Log 2x minus 3 to the base 3 is less than 2. First condition is this should be positive. So 2x minus 3 is greater than 0, or x is greater than 3 by 2. For second condition, we need to see whether the base is greater than 1 or it lies between 0 to 1. Conditions applied will be different. In this question, base is greater than 1. So the second condition will be 2x minus 3 is less than 3 to power 2. So this gives x is greater than 6. Combining these two, we can say that x is greater than 6, or x belongs to 6 comma infinity. We can match this result by applying formula also. So this matches with first one, and here x is equal to 2x minus 3, a is equal to 3, and p is equal to 2, and a is greater than 1, 3 is greater than 1. So direct solution is x is greater than a to power p. That means 2x minus 3 is greater than 3 to power 2. So you will get the same answer. Second question, solve for x. Log x plus 1 to the base 1 by 3 is less than 3. Now this should be positive. So this is first condition, x plus 1 is greater than 0, or x is greater than minus 1. Second condition, we need to see whether the base is greater than 1 or it lies between 0 to 1. In this case, base lies between 0 to 1. So the second condition will be x plus 1 is greater than. This sign will be switched. So it is greater than 1 by 3 to power 3. That means x is greater than minus 26 by 27. So combining this and this, we can say that x is greater than minus 26 by 27. We can match this answer by applying formula also. This matches with this, and condition is this. So the solution will be x is greater than a to power p. In this condition, x is equal to x plus 1, a is equal to 1 by 3, and p is equal to 3. So you will reach to the same solution. In next video, we will solve previous year's JEE questions. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.